So we want to share with you also some results, right? I mean, we show you some demo. We want to show you a mix of the lab testing and also the real world results that we collected over the last 6 months. So the first one is, I show you the on-demand remediation technique we did, right? With the forward error correction, with the jitter buffer. We also did some testing, right? To see what is the efficacy or how effective is that technique. And this is based on a single link result. So we compared the with and without VeloCloud. On the left is basically without VeloCloud, just run straight traffic through, and you have some degradation on the underlying network. So 2% packet loss, G711, the MOS score goes down to 2.1. But with our forward error correction scheme, we can keep it at about 4.2, 4.1.
And can you're able to report on that MOS score?
We talk about that. We don't use the MOS score. This is the third-party tool that we use for calibration, but we have a slightly different scheme for reporting, which we call VQS. I'll get into that in just a minute.
Okay. I just ask because I'm sure some IT organizations are probably under an internal SLA around a MOS score. Right. Whether that's a good idea or not, that's probably the case. So it'd be nice to be able to
you can report on
that right from the tool and show, yes, using this product, we've maintained our 4.3 or whatever.
Yeah. And then we do the same thing with jitter, right? 33 millisecond jitter brought down the MOS score to 3.3 without our optimization. But with VeloCloud, we can keep it at 4.2. The other thing we also did was, so we had collected quite a bit of data in the cloud, right? So since we launched the service, it's been 6 months. So what we thought, okay, let's go back and take a look at the data and see what we can learn from it. I mean, is the internet good or is the internet bad in terms of using it to carry enterprise application into the cloud, right? So we're curious to know as well. And also to use that to drive our product in terms of what optimization technique do we need to do, or do we do enough, right, to be able to make those internet links enterprise grade. So you asked about the MOS score earlier, right? So we use a slightly different approach, but it's still based on the same principle. So we come up with something called VeloCloud Quality Score. The reason is MOS score, right, is specific to voice. We want something that is kind of like generic, and you can apply that to represent the user experience. And we can do that for voice, we can do that for video, we do it for transactional application. And typically in the past, right, the metrics you get from the network is, I'm going to tell you, okay, you have 5% packet loss, 25 millisecond jitter, and 200 millisecond latency. What does it mean? So instead of doing it that way, we grade the link quality from the perspective of the application into green, which means good, right? Everyone is happy. Yellow, some of your users might not be happy, right? But the majority still are. And then red, if you keep that in the red zone, you can expect to get a phone call very soon, right? So do something about it. So at any given point in time, we grade the quality of the link, the underlying link, with respect to the application, what the user experience will be, right? And let's say if you are interested to know, okay, within the last 1 hour, what is the score of my link in terms of can it deliver a good VoIP quality? So we do a weighted average, and this is the formula that we use. It's on a scale from 0 to 10. So and then we basically 10 times the percentage of time that the link can deliver good application performance, right? And then we also add back the percentage of time that link can deliver just fair application performance, but we penalize it by using a multiplier of 5 instead of 10. Right? So you have this weighted average that can represent the quality of experience. So at the beginning, we thought, okay, are we the only one that think this is needed? So we actually went out, look around, and we came across the AppDex consortium, which is, it consists of a group of the APM vendors like CompuWare, Dynatrace, CA Technologies, with the same goal, right? That needs some metric, some measurement that can represent the quality of experience. And they use exact same formula, except that they are on the scale of 0 to 1, we're on the scale of 0 to 10. And this is something that we want to be working with them on.
But how are you qualifying good app performance or fair app performance?
Very good question. Let's take it to my next slide. So we calibrate it. So we calibrate it with real application, right? So we take a look at, okay, this is the different MOS score, and we use the ITU scale. And we say, okay, anything above 3.6 is considered good, right? So what we did was we start to do the calibration with different tools, PacketSmart, Visualware, SIP Trinity, IP phones. So we find a network condition that can deliver that 3.6 and above, right? We calibrate it, and then we know the network boundary that can deliver good performance. We repeat the same thing with 3.1 to 3.6, and anything below that fall into the poor category. So we do this calibration to basically come up with the network condition that we know can deliver the good, poor, and bad performance that we were looking for.
Can you tweak the color coding in the dashboard there in case your environment is, shall we say, extra sensitive? Yeah.
We actually set it to be quite aggressive. I mean, worst case. But if it's something that we heard from customer that it's something they want to be able to tune, and we can talk about that in the roadmap session. We cannot do that today. But we do have different measurement for voice, video, and transactional apps. So based on this principle, right, and this is how we use it to grade the quality of the link and also to drive the result of our study. So just some background on the data, right? We have about 6 million samples in our database as of December across 200 different links. And this is from basically POC, from live deployment that we have, right, active deployment. We cover about 50 cities and 50 ISPs. And we have a fairly good distribution across the different link types, right? Cable, DSL, Ethernet, fiber, and 3G, 4G, LTE. And the conclusion we had, and which is probably like not a surprise to many of you, right? 25% of the time, the internet link cannot be used to deliver real-time application like VoIP. Basically, 25% of the time, we see the yellow and red in the samples. And it's highly unpredictable, and regardless of how we slice and dice and group the data, it's highly unpredictable. And we have a few more slides that get into detail. And then I'll leave this one for the last slide. So basically, if I take that 25% and start to break it down into different link types, right, you see, as expected, Ethernet and fiber have the best performance, but still up to 8% of the time that it cannot deliver the good quality that we were expecting. Cable, and then followed by DSL and 3G, 4G. So what we found, I mean, majority of the data still come from the US. So what we found is, for some reason, the customer that use DSL are in a not so good location. And that may be the reason why DSL is not as good as all the other ones.
Where would like a FiOS service fit into this, a residential or a...
FiOS, we consider that to be fiber. Or like AT&T UVerse, we consider that to be DSL.
So, is this an independent test that you did?
It's something that we collect in our cloud, right?
Wow.
The data has been anonymized, aggregate, because everything that we run, because we run it as a service, we have all these sensors, right? That basically this is a sensor. And we have also another measurement point in the cloud, like all these cloud gateways. So they collect, aggregate the data, anonymize it, send it up there in the cloud. All we have to do is just go and analyze it.
So I just want to call out that I'm glad that you're looking at that. That data is important, and you've got a very unique view into it. And the fact that you're using that for analytics and stuff, I think, is nice. Because you have a very interesting set of data points that you can crunch and get,
Yeah. I mean, kudos to the engineering team. I'm just the guy looking at the data.
Well, fair enough.
But, and also one thing I want to point out is this analysis is based on local work hours, right? 8 to 6, we define it to be 8 a.m. to 6 p.m. local time, Monday to Friday. This one, I mean, we have the data down to individual ISP, but we do not publish it because we don't want to make our friends mad, right? But we do work with the customer, and it's something that we can share with the customer to help with the site selection, ISP selection. But the thing is, let's see if I pick one ISP that it looks like they have a pretty good performance. So now we zoom in, just pick one ISP, but they cover multiple cities, right? We still see a lot of variation across the different cities served by the same ISP, right? And this is multiple cities. Each bar represents one city. And this is even more interesting, right? If you pick a location, a link, let's say you pick one link and you zoom in and you look across time. So each bar is 1 week. And we see still, right, a great variation even here. Like the first 4 weeks in New York, this particular ISP in New York is doing very bad, and then it got really good for about 6 to 7 weeks, and then got worse again. I mean, the key point we want to make here is a lot of unpredictability that happen if you rely on just single link. Another thing is, okay, if I spend more money, right, pay for more bandwidth, do I get better reliability and performance? We don't see that trend at all, right? As a matter of fact, as the bandwidth goes up, right, and we pick the best two categories, cable and Ethernet, as the bandwidth goes up, you still see a lot of inconsistencies, unpredictability of the link. So what can we do? So we believe, right, that if you have one link, you have a risk. You put all your risk in that one link, right? So whatever problem you have no way to get around it. I mean, you may be able to do some forward error correction, but you reduce that risk by having two links. And the ability to switch the packet onto the right link at the right time, and you combine it with the forward error correction, jitter buffer, to mitigate all those underlying problems and keep performance of the application good. And with the technology like what we have, right, like the cloud delivered SD-WAN, and based on our analysis, we can actually take that 25% down to less than 1%. So what it means is during work hours, right, we should be able to deliver 99% performance that is expected by enterprise.
So this is actual results for the past 6 months.
And we will continue to monitor, right, and make adjustment over the next 3, 6, 8, 9 months.
This is primarily North American data, so as we get into Latin America, other places, the mileage will definitely vary. Collected as 4 minutes.
4 minutes.
Especially as part of the service.
Well, I think the metrics should actually be better international, would they not? Because historically, the links are much less reliable. So if any error correction that you're doing, any of this automatic recovery and dynamic load balancing, all this other stuff, should actually be a greater gap. I would assume.
It's going to increase your business case.
Yeah, exactly. It'll increase your business case.
Yeah. Okay, I have 1 minute.
Yeah, 1 minute.
1 minute, okay. So at the same time, in some of these locations, we deploy test tool, right? So we want to also measure the real voice calls and see how we are doing. So in some of these locations, we do deploy some tools to do collect additional data for us. And what I'm sharing is a weekly data that we got. I just pick 1 week from one of the locations that we do from East Coast to West Coast. And the test, we actually run G729, 5 concurrent voice calls continuously. Each call lasts 1 minute. And this is the setup, right? We want to actually mimic the flow of, if this is a hosted UC, right, the call might go up there and come back down, right, even when you do call between 2 locations. So we have the parallel setup, one without VeloCloud and one with VeloCloud. So it's surprising, but I'm very happy to see the result that 99% of the calls, right, during work hours, we are able to maintain 99% of the calls above 3.6 mod score with a good concentration around 3.9 to 4.0 compared to without VeloCloud, it is staying around 3.5 to 3.6. And we also have another view that show over the weekday. And the interesting part here is, the blue line is with VeloCloud. This is the mod score. The gray is the traditional, and you see this dip that happen almost every day, that's when everyone goes home and start downloading Netflix and streaming video. But the good part is it happened after work hours. That's when internet get the most busy. I just did the fastest presentation of my life. Hopefully it's useful, and thank you so much.
Thank you.
I'll have the clicker. So folks, a little bit of a time check here. We have about 7 different customer case studies, but I don't think we will be able to go through many of them. So we have DevCon Construction as one of our key customer. We have Redmond Inc., one of the top retailer from Utah and Colorado, as another customer case study. But in the interest of time, we are going to take this during the lunch hour, and now we will go straight into the roadmap session and take up some of the questions that you are asking and go deeper into it.